The next problem, it says a rancher has 200 feet of fencing with which to enclose 2 adjacent rectangular corrals. You can see the picture that was given. What dimension should be used so that the enclosed area will be a maximum? Using my strategy, the first thing I'm supposed to do is figure out what's to be maximized or minimized. So if I go back to here, it says that we want the area to be a maximum. So I'm going to maximize or find maximum area. The second part of my strategy is appropriate equations. Well, I know I need to use 200 feet, and what that refers to is it's telling me that I have 200 feet to cover all these red lines. So I have X, X, and Y. So I have 4 X's and 3 Y. The second equation has to do with what I'm supposed to be maximizing or minimizing, in this case maximizing the area. This side has a length of 2x, so the area would be 2x times y. I am going to do the third part, which is to write the equation to be maximized and minimized as a function of one variable. So I'm going to go ahead and solve for y on this problem. When I solve for y, I end up getting 200 minus 4x equals 3y. Divide by 3, and I end up with this y value. That will allow me to come over here and write this function as a function of one variable, 2x times, instead of the y, I'll have 200 minus 4x over 3. I don't really want to take the derivative of that yet because it says to find the critical points, and I know that means I have to find the derivative. What I want to do is I don't want to end up having to do a product rule, so I'm going to distribute this through. So that gives me 400x minus 8x squared over 3. Now I don't really like this 3, but it's really just a constant of 1/3, so I'll pull it out front. And then if I want to even, I could take out an 8, which I will go ahead and do. So I now have the area equation to be 8/3. And then that would be 50x minus x squared. Now you might be wondering, why didn't I pull out an xt? Well, then I'd be back to doing a product rule. And by just pulling out this constant, I'll be able to figure out my first derivative. And when we take the first derivative and we have a constant out front, we can just write it. So it actually just makes things a little bit easier. So what I'm going to end up getting here when I take the derivative of what's inside is 50 minus 2x. So I'm going to set this equal to 0. And what I then can do, I can really get rid of this fraction, because when I divide by 8/3 on both sides, I get 0. Move the 2x over, and I get my x value is 25. So what that's basically telling me is when x is 25, it's the maximum, supposedly. You really should check your critical numbers to make sure that it's the max. So I will go ahead and do that in this problem. If I plug in, let's just plug in 1, that would be to the left of this. I don't want to plug anything lower than 1 because 0 would be considered one of those endpoints. And endpoints in this problem, which it does say check the endpoints, doesn't make any sense because if you have 0 amount of fencing, you're going to end up with 0 amount of area. That doesn't make any sense. We're not going to use 200 feet of fencing on just the x parts because then we'd have no y parts. So again, this is one of those problems where the endpoints don't make a whole lot of sense. So when you plug 1 into your derivative here, you end up getting 50 minus 2, which is positive. And then when you plug in maybe like 26, you get 50 minus 52, which is a negative. So you can see it's increasing and decreasing. So this is definitely a maximum. The question though asks you to find the dimensions. So the x dimension is 25, and we're yet to find the y dimension. We're going to find the y dimension by plugging it back in right here. So when I plug that in, I get 200 minus 100 over 3, which gives me a y value of 100 over 3. Those would be the two dimensions that give us the maximum area.